Section 7.2a is about substitution. Substitution is a method. It's an algebraic method, a method that uses algebra that you can use to solve a system of equations. So it's another way to solve a system other than graphing, and this time it's using algebra. It involves solving for one variable in terms of the other. Now the key to substitution is this. You have to isolate a variable. Once you isolate a variable, you can then go ahead and do substitution. Let's look at an example. Here we have to use substitution to solve these two equations, this system. The problem with solving is that you can't isolate two letters. You can only isolate one letter. So watch what I'm going to do. I'm going to take this y, which is already isolated, and I know that y equals 3x. Well, if y equals 3x, we know that y is the same as 3x. And any place I have a y, I can substitute a 3x in its place. So I'm going to take this 3x and I'm going to put it in for the y. Now, why can I do that? Because they're equal. So watch what happens. I'm going to rewrite this as x plus 2y. Instead of a y, though, I'm going to substitute 3x. Maybe putting that in green might help you see it a little bit better. And that still equals negative 21. That is substitution right there. You in a sense combine the two equations by substituting one of the other variables that's isolated, and you figure out what that equals, and you put it in place of that variable in the second equation. Now in this equation, I'm going to get x plus 6x equals negative 21. Now these are like terms. Since they're like terms that are on the same side, I'm going to combine them. So 7x equals negative 21, and I can solve that because I only have one letter. Divide both sides by 7 using algebra. So x equals negative 3. Now that's only half of my solution because I still need to find what my y value is. So I'm going to take this x equals negative 3 and I'm going to substitute it again in for this x, because now I can use that to solve for y. So I replace the x with a negative 3 and I end up that y equals negative 9. Now, because we're talking about a system of equations, go back to the graphs that we've been learning about in the last section. If I have an x that's a negative 3 and a y that's a negative 9, that's a single ordered pair. Which means if I were to graph these two equations, they would cross in one place. And where would they cross? Right here, negative 3, negative 9. Here's an example where we have to use substitution, but unlike the last one, there is no variable that's isolated. So I'm going to rewrite these. So I'm looking at these and I'm trying to figure out which letter would be the easiest one to isolate. And the answer is the one with a coefficient of 1. Because all I have to do over here is subtract 5y. So I end up with x equals negative 3 minus 5y. Now I can do my substitution. Because x equals all this green stuff, I can plug all that green stuff in place of x. That's the goal. Isolate one of the letters and then plug all that stuff into the second equation. So now we have 3 times negative 3 minus 5y minus 2y equals 8. Now I'm going to do algebra here. Distribute the 3, negative 9 minus 15y minus 2y equals 8. These are like terms that are on the same side, so they just get combined. Negative 15 minus 2 is negative 17. And that equals 8. Add 9. So negative 17y equals 17 and divide by negative 17. So it looks like y equals negative 1. That's part of my solution. It's not the whole thing, because now I got to find out what the x is. The best place to do that is where the x is isolated. So I'm going to take that negative 1 for y and put it right there. X equals negative 3 minus 5 times negative 1. So negative 3 plus 5. So x equals 2. Now when you write your ordered pair, some people will mistakenly write this as negative 1, 2 because they solve for the negative 1 first. You don't do that. You put the numbers in alphabetical order, so the x comes first and then the y. Here's another example involving substitution. I have a letter that's isolated, which is good. So y equals all this stuff. So I'm going to take all this stuff and plug it in place of the y. So 6x minus 2 times, instead of y, I use 3x plus 2. There's my substitution step. That equals negative 4. So now the distributive property, 6x minus 4 equals negative 4. These are like terms that are on the same side. 6x minus 6x is 0. So we get negative 4 equals negative 4. All of the letters have canceled off. And if you remember, we've learned this in the past, that when all the letters cancel off, there are two possible solutions. Let's review that. If the letters cancel off and your equation is true, then your answer is all real numbers. That's the symbol. And if your equation is false, then your answer is no solution. No solution means there's no answer. All real numbers means that every number to plug in for the variable works. Now, this one is true. Negative 4 does equal negative 4, so we say the solution is all real numbers. Now, just to let you know, another name for that is a dependent system. When all real numbers is your answer, that's called dependent.